Hey guys, I hope you enjoyed your spring break and you're back and ready to learn some more. So today is going to be the last section in factoring, thank goodness. So lesson 9, factoring, part 6. So this is like the main idea. We had to do all of that work with factoring, figure out how to do it just to get to this point. And if you remember, I said the big picture of this whole entire chapter is how to solve a quadratic equation for x. And you can't just isolate the variable. It's a little more complicated because of that x squared component. So today we're going to be solving quadratic functions by factoring. So I'm going to put this away and bring back up our 4 steps of factoring. So the first step is still always factor out the common monomial. Second step, now that we know them, look for those special patterns. The first and the last term, if they're perfect squares, it's most likely a pattern. You had your difference of 2 squares in your perfect square trinomial. Step 3, if your leading coefficient of a trinomial was 1, just do the x. And then if your leading coefficient was not just 1, do the x in the box method. All right, so I'll leave this up here while we go through today's lesson. So, part 6, there's my pen. We're solving quadratic functions by factoring, and so this is review right here. We're going to write the equation in intercept form and then graph the function. So what form is this function in now? My dog. It's getting in trouble. No. Okay. X squared minus 8x plus 12. That would be standard form. And if we are asked to write it in intercept form, if I scroll all the way back to the beginning, intercept form looked like this. Y equals A times the quantity x minus p times the quantity x minus q. You could say that your intercept form is your factored form. So basically, what we've been asked to do with this quadratic function is to factor it. So it is in standard form, and we've been asked to factor it. So, steps of factoring. Is there a common monomial? No. Is it a pattern? The first term is squared, but the last term is not a perfect square, so it's not a pattern. Step 3, the leading coefficient 1? Yes. So all we need to do is the x. What number goes at the top? Your constant 12. What number goes at the bottom? Your linear coefficient, negative 8. And then you should be asking yourself, what times what gives me 12, but when I add them I get negative 8. So we're multiplying 2 numbers and getting a positive, but adding them and getting a negative. So both of them need to be negative. Again, you could list your factors of 12. Just a quick review of that. 1 and 12, 2 and 6, 3 and 4. So both of them need to be negative. You should find that it's both 2 and 6. So negative 2 times negative 6 is positive 12, and negative 2 plus negative 6 is negative 8. So then, writing them in their bubbles, x minus 2 times x minus 6 would be the factored form, but we're talking about an equation, so y equals. That would be converting an equation from standard to intercept form. And so to graph that, if you recall, intercept form, this is your p and your q. These are your x-intercepts. And I gave you a little hint, if something is in a bubble, the signs are most likely opposite because it's x minus the p-value, x minus the q-value. So your 2 intercepts, the p and the q-value, are a positive 2 and a positive 6. Those are your 2 x-intercepts. So plotting at positive 2, plotting at positive 6, okay? And then when we graphed in intercept form, if you recall, the vertex is halfway in between your sides because a parabola is symmetrical. So finding the value that's halfway between those two, which would be x equals 4. And so that is cutting our parabola in half. And in order to find the y value, plug in 4 for x. So I'm going to kind of running out of room here. I'll go over off to the side. Y equals 4 squared minus 8 times 4 plus 12. Plugging in 4 for x into our original equation. You also could have plugged it into the intercept form. That actually might have been easier. Yeah, let's do that instead. 4 minus 2, and then 4 minus 6. So 4 minus 2 is 2, times 4 minus 6 is negative 2, and 2 times negative 2 is negative 4. So the y value of our vertex is at negative 4. Again, going way back to the first lesson, our a value is positive 1, so our parabola is opening up, and it's neither stretched nor compressed. It's following that parent graph pattern. So from the vertex, if we were to go over 1, we would go up 1, over 2, up 4, over 1, up 1, over 2, up 4. We could go over 3, up 9, but we already have sufficient amount of points to draw in our curve. So there's our parabola. And the whole goal of being able to solve a quadratic function is to find those two x-intercepts. So like we quickly factored this and then said the p and the q values. So in your blanks here, the x-intercepts of the graph of y equals a times x minus p times x minus q. So that's just your intercept form. So those intercepts are p and q. These are also called the roots of a function and the zeros of a function. Okay, so intercepts are called roots and zeros. Same thing. They all just mean where that parabola is crossing through the x-axis. All right. So basically, if you have a quadratic in factored form, you can quickly solve for x. So example 1 is already factored for you. And in order to find where that parabola is crossing the x-axis, you need to find those x-intercepts. So an x-intercept is where your y values are both 0. This is the point 6, 0. This is the point 2, 0. Okay? Your y value is 0 whenever you're finding an x-intercept. So in order to solve, once it's factored, you're setting both of those bubbles equal to 0 because you want to know when y is 0, what is my x value? So taking the first bubble, x plus 3, and if x were 0, or I'm sorry, if we were solving for 0, we would have to subtract 3 from both sides, and so then x would be negative 3. There's one x value, and then take your second bubble, x minus 1, set it equal to 0. So we would have to add 1 to both sides, and x equals positive 1. So these are the two x-intercepts of that graph. The a value is 1, positive 1, so it's opening up, and it's neither stretched nor compressed, and then this is where it's crossing through the x-axis. So once it's factored, it's easy. This one was already done for us. But example 2, it is not factored. It's in standard form, so you need to factor it. Step 1, is there a common monomial? Always check for that common monomial. X squared minus 2x minus 8? No. Step 2, is it a pattern? Is your first and your last term a perfect square? No. Step 3, is your leading coefficient 1? Yes. So you just have to do the x. Negative 8 goes on top, negative 2 goes on the bottom. What times what gives you negative 8, but when you add them together, you get negative 2. So negative 4 and positive 2. That goes into your bubbles. So you have x minus 4 times x plus 2 equals 0. Okay. Notice these are equations now set equal to 0. It's because we're trying to find those x-intercepts. And again, once you have your bubbles, just set each individual bubble equal to 0 and solve for x. So you're basically taking like two mini equations and solving them separately to get those two x values where it's crossing on the x-axis. So x minus 4, set that bubble equal to 0, add 4 to both sides, and x equals 4. So you would have a point on the x-axis at 4. And then your second bubble, x plus 2 equals 0. Subtract 2 from both sides. And x equals negative 2. So there are your two x-intercepts of the graph. Your roots, your zeros, okay? So really the hard part was just learning how to factor, because once it's factored, you're just setting those bubbles equal to 0 and solving for x. But where it gets a little more fun would be one like example 3. All right, so steps of factoring. Is there a common monomial? 3x squared, 10x plus 3 equals 0? No. Is it a special pattern? Well, are your first and last terms perfect squares? No. Is the leading coefficient 1? No. So step 4, x in box. If you recall, when your leading coefficient is not 1, the first thing you need to do is multiply a times c. So 3 times 3 is 9, and then your middle coefficient goes at the bottom. So what times what gives you 9, but when you add them together you get 10. Pause and think about it, or wait for me. But you should come up with 9 and 1. 9 times 1 is 9, 9 plus 1 is 10. Next you need to plug them into your box. So, top left box is your first term, 3x squared. Bottom right box is your constant, 3. And then those two diagonals are the numbers that you just came up with, but add your variable back. Doesn't matter which spot you put them in. If I put 9x here and 1x here, that's fine. It doesn't matter. And then taking the top row and factoring out the greatest common factor, greatest common monomial, 3x squared and 9x. The biggest thing you can divide out of both of those two terms is 3 for the numbers, and you can take an x out of each one. So 3x. And then working backwards, 3x times what gives you 3x squared? X. 3x times what gives you 9x? 3. X times what gives you 1x? 1. So there are your two bubbles. You've got 3x plus 1 times x plus 3. So there is your factored form, but it's an equation. And then we need to solve for x. So the factoring part is done. Now we need to solve for x. So take each bubble and set it equal to 0. 3x plus 1 equals 0. So you would have to get x by itself. This one has an additional step compared to the last one we just did. First, we would need to subtract 1 from both sides. So we would get 3x equals negative 1. And since we're trying to get x by itself, right now it's 3 times x, so to undo that, we would have to divide by 3. So divide by 3 on both sides, and x equals negative 1/3. You could also leave that as negative 0.3 repeating if you wanted to do the decimal instead. So there's one of the x values. Next we have to set the other bubble equal to 0. X plus 3 equals 0, and then solve for x. So subtract 3 from both sides. Subtract 3. X equals negative 3. If you can do that math in your head, by all means do that math in your head. Just be very careful. If there are 2 steps, maybe work that out so you're watching your signs, but by all means, if you can look at that and say, oh, I'd have to subtract 3 to get x by itself, x equals negative 3, do it. You don't need to show me that step right there. All right, number 4. 4x squared minus 1 equals 0. So this one should look a little different. Step 1, is there a common monomial, 4x squared minus 1? No, there are only 2 terms, so that should kind of be a light bulb in your head. Step number 2, look for a special pattern. Was there a special pattern that only involved 2 terms, and perhaps the difference of them? Is 4 a perfect square? Is 1 a perfect square? Yes, yes, yes. So this is a pattern. The difference of 2 perfect squares. Difference of 2 perfect squares means you're going to have 2 bubbles. So that factors to 2 bubbles. One that's plus, one that's minus. Okay? Because remember those canceled out the middle term? The square root of the first term. The square root of 4x squared is just, I didn't make these big enough. Yeah, there we go. 2x. The square root of 1 is 1. So there's your factored form, set equal to 0 because it's an equation, and then you're taking both of those bubbles and setting them equal to 0 to solve for x. The only difference is the sign. So for the first one, if you take 2x plus 1 and set it equal to 0, you're going to subtract 1 from both sides. So 2x equals negative 1, and then divide by 2 on both sides. So x equals negative 1/2. Well, since the only difference here was the sign, can you foreshadow? 2x minus 1 equals 0. If you add 1 to both sides and then divide by 2, x is going to equal positive 1/2. So your 2 x-intercepts, your 2 roots, your 2 zeros of that function are positive 1/2 and negative 1/2. And there you have it. Next. This one looks a little bit different. X squared minus 14x equals negative 49. So on all the other ones, they were set equal to 0. So you do have an additional step before you can begin factoring. First, you need to add 49 to both sides so that it was set equal to 0. I'm going to have you finish that one on your own. Okay, factor that and solve for x. Follow the steps. Is it a special pattern? Maybe. Or, again, if you forget the patterns, you can always do it the long way. The x or the x in box if you want to. Okay. 6. Again, it's not set equal to 0. So, set it equal to 0. We would need to subtract 30x from both sides. So 5x squared minus 30x equals 0. Again, there's only 2 terms. Now we can factor it. The first step, factor out the common monomial. Is there a common monomial? 5x squared minus 30x. You can factor out a 5x from both of those 2 terms. So 5x. And then what's left? X minus 6. So this looks slightly different from what we've done in any of the other ones because that common monomial was the only thing that we could factor out. We have a 5x and an x minus 6. We're done. We're done factoring. In order to solve for x, if your common monomial has an x in it, you must also set that equal to 0. So to solve for your 2 x values, 5x equals 0, that's like its own bubble, okay? So then dividing both sides by 5 just gives you x equals 0. And that's okay. You can have a parabola crossing through, that's technically at the origin, right? Because when y is 0, that's what you're solving for. So you can have a parabola crossing through the origin. And then this bubble, x minus 6, set that equal to 0. Add 6 to both sides. So x equals positive 6. Okay? Cool? Cool. Example 7 is a little messy, but no doubt I think you could know what to do with it. I'll get you started so that it looks like what we're used to factoring. you've got a set of parentheses, and then plus 17x, and then something over here on the other side of the equal sign. So you need to get it to look like what we're familiar with, like a trinomial in standard form, so that you can factor it. So first, let's distribute this 2. So that gives us 2x squared minus 40, and then plus 17x equals negative 10x squared. Now let's set it equal to 0. So we could add 10x squared to both sides. Okay, that's like combining like terms. So we need to add it to the x squared term over here. So plus 10x squared. So we end up getting 12x squared minus 40. Whoops, I'm going to actually write this so that it's in standard form. Plus 17x minus 40 equals 0. Okay, 12x squared plus 17x minus 40 equals 0. Now that's in a more familiar form. You could factor it. Is there a common monomial? 12x squared, 17x, and 40? No. Is the special pattern? Are 12 and 40 perfect squares? No. Is your coefficient 1? No. So you would have to do x in box for this one. 12 times 40 is going to be a very large number. So it might take you a minute to come up with these two numbers, but I do want you to finish this one on your own. Okay, you're going to do x in box to factor it, and then set those two bubbles equal to 0 to solve for x. If you have questions on that one, list it in the comments, or if you think you have the answer, email it to me. I can check it, but that one should be a good one. Number 8, again, put it in a form you're familiar with, so get it in standard form first. We've got it's not equal to 0. We've got terms that need combined, things like that. So first we're going to, let's subtract 2x squared from both sides. So 8x squared minus 2x squared is 6x squared plus 5x. And we could subtract the 4 from both sides too while we're at it. So minus 4 equals 0. Again, it is now in your standard form set equal to 0. Steps of factoring: 6x squared plus 5x minus 4. No common monomial. 6 and 4, not perfect squares. Leading coefficients, not 1. X in box. Okay, so let's also... actually, I'll do this one with you. Okay, so x. Oh, there we go. 6 times negative 4, negative 24. 5 goes at the bottom. What times what gives you negative 24, but when you add them, you get 5. 1 needs to be negative. So you would have 8 and negative 3. 8 times negative 3 is negative 24, but when you add them together, you get positive 5. Now plug into your box. (6x squared) goes in your top left, negative 4 bottom right. The two numbers you just came up with, 8x and negative 3x. Greatest common factor of 6x squared and negative 3x would be 3x. Remember, only factor out the positive. Don't factor out the negative because that one's not negative. 3x times what gives you 6x squared? 2x. 3x times what gives you negative 3x? Negative 1. 2x times what gives you 8x? 4. Just 4. So you have 3x plus 4 times 2x minus 1 equals 0. We did not have a common monomial, so we don't need to reattach it at the end. But then solving for x, you have to set both of those bubbles equal to 0. So 3x plus 4 equals 0. Subtract 4 from both sides. Divide by 3 on both sides. So x equals negative 4/3. Remember, I love those improper fractions, so you can leave it like that. You could also say that's negative 1.3 repeating. Okay? I would accept either one of those answers. Okay, the second bubble. 2x minus 1, set it equal to 0. Add 1 to both sides. Divide by 2. So x equals 1/2. You could also say 0.5. There's your final answer. Okay? -4/3 and +1/2. Remember, I'm going to upload these keys on my tab under the school website, so if you didn't get a chance to see it here, you can always go back there. Number 9, I want you to do on your own. I will give you a hint. First step of factoring, factor out that common monomial. And step number 2, look for a special pattern. Okay, so there are only 2 terms. You'll have a common monomial and a special pattern. All right, and that concludes solving quadratic functions by factoring. So the next lesson, we're going to move on to something a little bit different. Again, if you have any questions, email me, comment, and I'll try to get back to those. As far as me collecting this, I'm not asking you to send me any photos of your work right now. I will probably be doing that soon, since we just finished like the factoring part. I'll probably ask you to send me what you have so far, and then we're going to do the next part. I'll have it send it to me. So again, look at your emails. I'm going to be sending out soon. Have a great day. Let me show you the little guy here. He took a nap. Nobody gave me a guess as to what his name is yet, but he's growing like a weed, keeping me busy. Just say, hey. Okay, bye.